So I'm going to try to encourage you, Joshua, not to give up, but to do the best you can, no matter how hard it is. And I have 4 encouragements to keep you going. Number 1, God made the world to be full of math. Now you know, Joshua, that numbers are like words. You may not have thought about it. The word dog stands for a real animal, and we call that real animal by the word dog. But a real dog is not a word, right? It's a real animal. So the word D-O-G, dog, is just a name. It's just a name for something that's real. So words help us talk to each other about what's real. Without words, all we can do is point. So words are really useful, even though they're just names. They're not real things, but they name real things. Now, that's the way it is with numbers, too, right? Numbers are like words. They stand for real things, or amounts of real things. For example, if you have 2 banana trees in your backyard, which we did when I was growing up, and on one banana tree, there are 4 bananas. And on the other banana tree, there are 4 bananas. And the next day at school, somebody asked you, Joshua, how many bananas are growing on the trees in your backyard? Well, you could say 4 on one tree and 4 on the other tree. Or you might say 8 bananas, because 4 plus 4 is 8 bananas.
Does everybody agree with that? Good. All right. So we're on the same page. 4 plus 4 is 8. But I have a question because someone in my last class actually has one of these. Does anybody have a banana tree?
No.
No? They said that they actually grow bananas here in Georgia. I didn't know that was possible, right? So they actually have a banana tree in their backyard. It's not in a greenhouse or anything. They just have a banana tree and it grows bananas. So I was kind of impressed by that.
Cool.
But anyway, you want to be able to tell your friends how many total that you have, right? So you need to know math so that you can say, I've got 8 bananas. If you had to say I have 4 on one tree and 4 on the other, think about how long that would take if you said that about everything. Isn't it much more convenient to say I have 8 bananas, right? So math is kind of convenient, right?
That's math. But those numbers represent real bananas. They're not just numbers. They stand for real things that you can eat and talk about. So God made a world of bananas and dogs and thousands of other real things that you can count. You can put numbers and names on them. That's the kind of world God made. So when we study math, we are trying to understand the way God made the world. This is God's world, and He loves it when His people, including 8-year-olds, study His world and understand it and use it for His glory.
So that's actually really important, I think, right? That's maybe the most important point that he makes here. Why are we having to study math? Well, who invented math? Who's the ultimate inventor of mathematics? God is, right? The reason that math works like it does is because God established that, right? When you look over the history of mathematics and things have been developed, another class that I teach at another school is astronomy. And what we're studying classical astronomy in there. So we're looking at the stars and the sun and the moon. We're observing those things according to what God said the reason He created them in Genesis 1 was for times and for seasons and for years and stuff like that. And so for like centuries, those things have been used to tell time. It's only been like the 1800s where the development of clocks and then, more specifically, everybody having wristwatches, and now we've got these cool things that track your steps and tell you how old you are and whatever else, But we've got all these other ways to tell time now, so we don't even bother looking at the heavens to find out about that. But used to, everybody was taught that, right? And so one of the things that we found out in astronomy is that like entire mathematical disciplines have been developed through the study of the heavens and the study of the stars. So like trigonometry. Originally, that was developed because they were trying to figure out distances of stars and how far things were away and all that kind of stuff, and being able to direct people to say, hey, if you're going to see this star at this time, you have to look this many degrees up and off the horizon to see it. So that was developed primarily because they were studying astronomy. So the point is, they were studying God's creation, and they discovered something that God integrated to His creation, which is mathematics, right? So we're actually studying that which God has invented. And just like the Bible says in Psalm 19 that the heavens declare the glory of God, mathematics does that as well, right? It gives us some insight into the way that God thinks. If God determined to create it this way, and so it's worth us studying because we kind of grow in our wonder of Him, in our amazement of Him and what He's done. So I love that aspect of it. I like the fact that He pointed that out.
Which brings us now to the second encouragement. God made math very useful in this world. He made it to help us. you two stories, two illustrations. Suppose at the gas station where your parents fill up the gas tank of the car, you notice that they have a special of 3 chocolate candy bars for $1. And you ask your mom, can I have $1, please, to get those candy bars? And she says, sure, and here's $2. Get some for your friend. So you hand the man behind the cash register your $2 and ask for the candy bars, and suppose he hands you 5 candy bars and takes your $2. What are you going to say to him? If you studied math in the 3rd grade hard enough, like I tried to do, and you learned your multiplication tables, you would know that if you get 3 candy bars for $1, you should get 6 candy bars for $2 because you learned in the 3rd grade that 2 times 3 equals 6. No.
Does everybody agree with that? All right. So yeah, some of you didn't shake your head. I don't know. Do you know your 2 times tables, right? We don't need to go back that far in review, right? All right, so you guys know how to add, you know how to multiply. I'm happy. That's good.
5. And if you didn't learn that, you'd walk out with 5 candy bars instead of 6 candy bars because you didn't know your math. In other words, math is very useful for being happy. Just happy in this world because 6 candy bars makes me happier than 5 candy bars. And the older you get, Joshua, the more important those numbers become. Or here's a more serious story. You are squirrel hunting in the woods with your rifle, and suddenly 4 vicious wolves appear in front of you, and they show their teeth, and they look like they're going to attack you. And you know you can't fight off 4 vicious wolves and save your life. You might be able to fight off 1 wolf, but not 4. So you quietly check your gun, and you notice that you have only 3 bullets left in your gun. So you do the math that you learned in 3rd grade. If I kill 1 wolf with each of my 3 bullets, then only 1 wolf will be left to fight, because 4 take away 3 equals 1. And my life depends on this math.
Right?
So
yes.
you aim carefully and you kill 3 wolves. And when the 4th attacks, you're able to use your rifle and smash his head. Way to go. I promise you, Joshua, math will not only get you candy bars that you should have, math can save your life. You really can. Here's a 3rd encouragement. God made your mom and dad with lots of wisdom about what you need.
Wow, who's ever thought that about math? Math can save my life, huh? You agree with that? What do you think? Is that true? Can mathematics be can it be life or death? Could there be situations that mathematics are that important? Absolutely, right? So my degree's in electrical engineering, that's what I went to Georgia Tech for. And when I was there, one of the things that we had to take was a class that, I can't remember what the title of the class was, but the point behind it was how important it was as we're using our degrees, that when we do calculations, or when if computer programming, that's actually what I've done for the last 25 years. I don't like admitting I'm that old, but I am, is computer programming. And when you write a piece of software, and some of that involves calculations and all, when you do those calculations, then it's important that you get them right, especially in certain scenarios, because some people are writing software for things like air traffic controllers, right? And so if there's a bug in that and planes are on a collision course, yes?
There was actually an instance where they did all 2 groups,
right?
2 different foreign groups were working on shuttle to send to Mars. And they did all the calculations correct, but one used the metric and one used the US. So
I teach that in my chemistry class. I remember reading about that. You're right. So units are important, right? That's one of the things that we learn in math and science, and just doing the calculations properly. I still remember an example that they used in class. I mean, this really happened where someone had designed, I guess their job was to design this radiation machine that they were using to treat for cancer treatment, right? And something was off with the calculation. Something was wrong with the software when they built it. And this guy went in to get radiated, and it actually radiated his whole body. It gave him way more radiation than he should have had because there was a bug in the software. And he ended up dying from it, right? So, I mean, it was life and death. And they were just stressing how important it is that we take the time, we take the proper measures to make sure that we're doing the calculations correctly, So math it's important that you learn it, right? You may need it in a situation where it's vital to have it.
For your future life, wisdom that you don't yet have because you're only 8. One of the reasons God gives kids parents is so that kids can learn about life from their parents and avoid hundreds of mistakes. It sounds to me like you have good parents, Joshua, so did I. And they would not let me quit when I felt like quitting because they knew what would be good for me. And I didn't know yet what would be good for me as I grew up. I wanted to play outside with my trunks in the dirt with my friend Sonny. That's all I wanted to do. I didn't want to study. I didn't even want to go to school. I didn't like school in the 3rd grade. But I am so thankful to God that He gave me a mom and a dad who knew what was best for me because I didn't know what was best for me myself. The Bible says, you know it, children obey your parents in the Lord. And I am so glad it said that, and I'm so glad that I did it. Which brings me now, Joshua, to the last encouragement. God.
So, yeah, if for no other reason you're here because the authorities that you're under say you have to be here, right? Whether it's your parents or the state in order to get a high school diploma, or whoever else. There's some authority that's saying this is required of you, and so you need to just do it because it's required of you. And that's what God tells us to do, right? To obey the authorities that are over us. And I wanted to share this verse in Colossians chapter 3 that is, let's see, down near the bottom there, where it speaks to bondservants in verse 22. Obey in everything those who are your earthly masters, not by way of eye service as people pleasers, but with sincerity of heart, fearing the Lord. And so when He's instructing them to work for their masters, and we can apply this to any kind of role of authority that we're under, do it and serve in a way where it's not just with eye service. In other words, you're not just doing a good job when the boss is watching, right? Or the teacher or the parents paying attention. You're not just trying to please people, but when you're doing it sincerely out of your heart because of your fear of the Lord, because you want to do what's right before God. And like he mentioned, children obey your parents. It's right for you to do that because God says so. And so the way that we should do our math, like everything that we have to do, whatever you do, work heartily, verse 23, as for the Lord and not for men, knowing that from the Lord you will receive the inheritance as your reward. You are serving the Lord Christ. And so we're supposed to do everything that we do for the glory of God, and so math is no different than that. So I'm hoping that will sort of set the tone, right, for the way that you apply yourself. I'm going to do my best to make this fun and not make the lecture too boring and all that, but we got to go through the details. I got to teach you the stuff. But anyway, it will make a huge difference if you go into it with this attitude of saying, you know what, I have to do this. Math may not be my thing, but this is where God's got me, and I need to do it for His glory, so I'm going to try my best, and I'm going to apply myself. Now listen to this last thing. This is really the whole reason that I was like, I've got to let my class hear this.
Made you to show how good and how great He is by trusting Him to help you. And God made me too. And guess what? He changed me. He changed me so that in the 10th grade, I loved geometry. That's a kind of math. Finally, there was a kind of math I really liked. It was like a detective story. You found the clues and you put the clues together and discovered the solution to the problem. It was like finding out who the bad guy was and putting him in jail. But Joshua, to be honest, apart from geometry, I was mainly afraid of math. And when I finished my final required basic math class in college, I felt like I had run out of a dark tunnel into broad daylight for the rest of my life. Never have to take another course in math. Hooray! I mean, it felt like a liberation coming out of jail. So here's the point, Joshua. Even though you don't like math today, you might like it someday because you grow and you change. Your brain changes. Or you might not grow to like math, and you'll be so glad when you don't have to study math anymore. And that's okay. God made you the way you are. You don't have to grow up to be a mathematician. But some math is good for everybody, I promise you. So my final encouragement is when your mom and dad say that you need to finish your math assignment, you should say, yes ma'am, or yes sir, and then whisper a prayer to Jesus. Jesus, please help me. I don't want to do this. I don't like to do this, but I'm going to do it because my mom says to, and Pastor John says it's good for me, so I trust you to help me. And Joshua, He will. And your trust in Him will show how great He is. Amen. Yeah.
All right. So, maybe math is not your thing, but I like the advice that he gives there. We should seek the Lord in that and understand God is able to help us in that. But also, maybe some hope for you where you're like, math isn't my thing, but he didn't like any of them except for geometry. right? So this may be the first time in your life that it's like, hey, this is actually kind of cool. This isn't like the math that we've done before. I was talking with some of the students before that you can kind of stick geometry in different places in your high school career. It doesn't necessarily have to be right after Algebra 1. Usually kids tend to take it then. But, and there are a few Algebra 1 concepts that kind of come over and you got to make sure that you remember. But for the most part, geometry is very different from the other maths. And so you might, like I said, you may find, like he said, that I don't really enjoy the other stuff, but this is actually kind of neat. So I'm hoping that'll be the case. If nothing else, you'll just have such an amazing teacher that you'll enjoy the class either way, right? So that's what my hope is. But yeah, let's do a good job for the glory of God. All right, so course outcomes, I'm not going to go through that. This is the syllabus. So did anybody not get the syllabus? I emailed that out to the entire class. You're not sure if you got it? So double check your email. I think I also put it in the Google Classroom. That's actually what I should ask. Does anybody not have access to the classroom yet? You still don't?
I checked a few minutes before I got here. I didn't have an invitation.
Oh, you did not? Okay, that's interesting. Well, so what I did is I sent a link out in this email that that should have gone to the entire class. And let me see if Paul is on here. Paul Barnes. So your CONUS address got this email, and there was a link in that where you could sign up. For the rest of you that are, and for those that are in the class, were you able to use the link successfully and get in?
I didn't have anything in the class, but I did use the link. I did the thing right there.
Yeah. I haven't really added anything yet. It was just a matter of joining. So yes.
Yeah, one of the things that I noticed, it was a lot different than a lot of the other classes, whereas you can just go straight into Google Classroom and it shows that class and says, would you like to join this?
Right.
Whereas for this class, you have to go on that email and click the link.
You have to click the link. Yeah. So and I wasn't sure. Like I said, this is my first time at CONUS too, so I wasn't sure how teachers typically did it, but I knew that this link would work, right? So I was trying to that way, rather than go in and add everybody manually, which will send you an invitation, right? Then you should have just been able to click on the link and get in there. Let's add you real quick, Paul. That'll make sure that you get the invitation. So it is 20 students. Paul Barnes, invite. All right, so you should have an invitation now and can join us. Anybody else not in here? No? Okay, so I will be putting assignments in here. In fact, depending on how much time we have at the end of the day, my intention is to always write the assignment on the board as well so that we know it, but I ran out of time in pre-calc, because I was like, just look on Google Classroom, right? I'll have it there. And I'll send out an email too to let people know. But I will put the weekly assignments in Google Classroom as well, so you can go back there and always see what you're supposed to be working on. So let's go through the syllabus. Like I said, you should have gotten this email, which also has a copy of the syllabus. You don't have to print this out, it's just there for your reference, right? I do have my contact information at the top of that, including a phone number, and that is to only to be used in the utmost need, right? But email's the best way to get in touch with me. If you have a question throughout the week, definitely start your homework early, right? If you have a question, because it's going to be, if you're asking me like come the weekend, I'm trying not to think about school at that point. So let me know something during the week. You guys don't want to think about school during the weekend, right? If you don't have to. So try to. So it's Monday. Go ahead and start on your homework early in the week, and so that you can ask questions before the weekend rolls around, and hopefully get answers to it. Does everybody have their book? I know there's at least one person that didn't, and I sent them it was you, right? Okay, so you've got, I made a PDF just of the first few pages.
I don't have mine.
Okay, you don't have, did I send you the PDF?
No.
Okay, let me make a note of that.
Okay.
And I will send you that just so you can do your homework. Have you ordered it though?
We're going to.
Okay, all right. So tell me your name again, please.
David Waterhouse.
David Waterhouse. Oops, not Dad. Not Dad Waterhouse. David Waterhouse. Is it just like that?
Yep.
Waterhouse. Send PDF of book. All right. Anybody else in that boat? Yes. Tell me your name again.
Piper.
Piper. Okay. Did I send it to you already?
I think you did.
Okay. I think I did. Yeah. So yeah, just need to send that to David. Make sure you get that ordered if you haven't already. Some people are having trouble that ordered it late, and there were just a couple that didn't seem to ever get the first communication that I sent back in June. Or if you joined after June, as soon as I got notice that somebody was joining, I would send out the welcome email that had the book that was required. But some of you that didn't get that, are having trouble finding this, the worked out solution key. Now this has the answer to every problem in the book in here, and I have looked high and wide trying to find a PDF version of this that I could just give to class. The teacher that taught it last year for pre-calc had a PDF version of the pre-calc one that I'm able to give students, but I cannot find a PDF version of this. And for whatever reason, when I sent the email back in June, these things were like $10. Now, like the cheapest one I'm finding is $80 and something, right? So if you don't have one yet and you're having trouble finding one, let me know. It's possible that we can reach out to, as I understand it, there's like a Konos Facebook page that people can, is anybody familiar with the Konos Facebook page? Yeah, can you post comments and stuff on there? And
I think you can.
like, I'm thinking maybe that would be a good place to go and just say, hey, my kid's taking geometry, or I'm taking geometry and I need the worked out solution key. Is anyone interested in selling it or letting me borrow it for the year? You know, something like that. So maybe there's a way that you could get it like that. But at some point, you're probably going to need that. Now the book has, yes?
I think I only have that one. I don't have the textbook.
You only have that one and you don't have the textbook? Okay, all right. So yeah, you're going to need the textbook. Well, the textbooks are still reasonable. So that is listed in the syllabus that I sent, which textbook you need to order, right? It's got the number here. But yeah, you definitely need to get that as well so that you do the homework. So I will send you an email as well. What's your name? Kylie what?
Stockman.
Kylie. Tell me your last name.
Stockman.
Stockman?
Mm-hmm.
Is that right?
STOCKMAN.
Okay. So go ahead and order that. There should be some used ones available somewhere. But like I said, the Facebook page is never a bad idea if you could just post it to everybody that's on there and say, hey, does anybody have one that you're interested in selling, or letting me borrow, or letting me rent from you? Who knows what people would be willing to do. You are going to need a scientific calculator for the class as well. I listed one that's an option, right? The TI-30 that's at Walmart, and they're not that much. But any scientific calculator, it's got to be a scientific calculator. You're not allowed to use your phone as your calculator, so I need you to have a scientific calculator.
Does the TI-30XA work?
Probably so. The main thing is it's got to have sine, cosine, and tangent on there. So does it have those trigonometric functions?
I don't have
Do you have it with you?
No.
Okay. So your calculator, just make sure it has the trig functions. Sine, cosine, tangent, because we are going to use those at one point in the class. So it should have buttons that say, that look like that.
I have that one in front of here.
Ah.
You have the same one?
Yeah.
And they have it on it?
Yes, sir.
Okay, cool. So make sure you bring your calculator to class, because most days, not today, because I hate giving homework over the summer. It's like, that's just mean. Why would you give your kids homework over the summer? Make the first day of class be the first day of school. So I shouldn't say that though, because there are other teachers that do that. I'm sorry, they're not mean.
Yeah.
They have a lot of material to get through. So
Especially the Tuesday.
I'm not that kind of guy. So, but from this point on, we're going to have a quiz at the beginning of most classes, right? Unless we're doing a test in class, we're going to have a quiz. And the point of the quiz is to just make sure that you guys are seeing the problems again. It's the same problems that you did on your homework. So every week, first 10 minutes or so, we'll take a quiz that's over the homework that you just did the previous week. So that means make sure you're on time, right? Because we don't have time to wait on somebody to get done. If you come in 5 minutes late and when we started right on time, then you've only got 5 minutes to take the quiz. So make sure that you're here on time so that you have the full time to take the quiz. And like I said, the problems shouldn't be a surprise. They're the same problems that you did over the homework. So it's just another way to reinforce that. Anybody can do math. I mean, really and truly, it's just some people have to do, my calculus teacher in college, I remember him saying this, and it's always stuck with me. Some people just have to do more problems, right? Some people, they get it, and they remember it, and they do a couple of problems, and they're fine. They can do it again on a test later on. Some people, they just have to do more problems. So if you find when I'm giving you a homework assignment, like often the homework assignment will say only do the odd problems, and the reason that it says that is because the answers to the odd problems are in the back of the book. So you can check your answers yourself. But you may find that, I need some more practice with that. We'll do the even problems too, right? Maybe you don't do all the even problems, but if you're having trouble with a specific concept, do the even problems in that area of the homework, and if you've got the worked out solution key, then you've got answers to the even problems in there as well. So doing more problems is going to help you, and so that's what the quiz is for, right? It's to give you another opportunity to see the problems, to see them in like a low stress quiz setting, only counts 20% of your grade instead of 40% of your grade. And so you can, and also so that you can take the quiz and then say afterwards, hey, I really bombed number 3, could you go over that? So we can work on that on the board as well. So it gives you an opportunity to ask questions about that before you see it on the test, all right? You will need some tools for the class: ruler, protractor, compass, colored pencil. She had that on the syllabus last year, so I'm not sure yet where in the class I might require you to use colored pencils. I'm not sure if that's necessary, but most of us probably have some colored pencils at home. And you can just wait until I give you an assignment that requires it before you have to actually buy those. Supposedly it says we have some in class. I don't know where they are. Maybe she's got some in the closet here. But you will need something for notes, right? So a 3-ring binder or a spiral-bound notebook, something to keep your geometry notes together in. Make sure you're taking notes when I write them on the board, right? That's, again, just another way to reinforce the concepts in your mind. Some people learn auditorily, right? They just listen to someone talk and they process the information. Some people visually, they have to see it. And just about for all of us, when we write it down ourselves too, it just kind of helps reinforce that. It helps us commit it to memory. And then there will be times that graph paper will be useful because we'll have to graph some stuff, okay? Any questions about materials that are required? I don't have a question. I don't know why I have a hand up. Oh, yes, you have a question.
Could you just buy the textbook and solutions key off Amazon or not?
They're there. But like I said, I don't know what the price is of the textbook now because I didn't realize anybody had ordered the textbook yet. But the solutions key, the cheapest one on Amazon right now, a used one's $85. So yeah, I looked all over the place trying to find another used one. So that's why I'm saying the Facebook page may be a good option for tracking down that solution key. All right, grading categories: homework and class participation. If I write, so class participation, let's talk about that a second. Move my name over here so that nobody forgets my name and calls me Mr. Dude or something like that. So you have 100 on your class participation grade right now. All right. So and homework. I am not checking your answers on your homework. All right. You guys are supposed to be, you're in high school now, all right? You're supposed to be, parents should be sort of stepping back and you're kind of handling things on your own. We're getting you ready for college, right? There's going to be no hand holding in college, right? Professors just aren't going to care. And so, we're trying to prepare you for that college environment, and that means you've got to take responsibility for yourself. And so as far as homework goes, I'm expecting you to hold yourself accountable, right, in doing your homework. If you've got the worked out solution key, you have the ability to go in there and do the homework and look at the solution key and just copy that down and do your homework that way. You're not going to learn a thing from it, right? And you're going to if you hand that in to me, I'm going to see a bunch of worked out problems and I'm going to say, check, you get credit for that. But you won't have learned anything. And so then when you take the quiz, you're going to be lost. And when you take even worse, when you take the test, you're going to be lost. So it's your job to make sure that you understand the material, right? All that I'm doing each week is I'm just checking to make sure that you did your homework. I do want to see your work. So, not just a bunch of answers written down. I want to see that you worked it out. Unless it's one of those problems that it's just like, well, you just know the answer and you write it down. Rarely is that the case in math. But my point is this: homework is an easy 100 for the year. Just do all of your homework. And class participation, you've already got 100 just because you showed up, right? So unless you're disruptive or rude, or make gross noises in class or something like that, you're not going to lose any points. You've got 100, and the only place you can go from here is up, right? And the way that you go up on your class participation grade is by participating in class, right? It's class participation. So as you participate in class, I may write your name on the board. And if I write your name on the board up here, that means for that week you get an extra point on your class participation grade. And so that resets every semester. But at the end of the semester, I don't know, we've got 16 weeks, something like that in the semester. So instead of 100, you could finish with 116 as your class participation grade, all right? If you're participating in class. You got to come out of your shell and you got to talk, right? You don't necessarily have to have the right answer. Maybe your answer's wrong. But if you have the guts to speak up and participate in class, then I'm going to reward that effort, okay? Weekly quizzes, like I said, every week, about 10 minutes at the beginning of class. Chapter, unit exams, those will count the most. And so typically after every chapter, or depending on, we just don't have time to cover the entire book during class. So some chapters we're only going to do like half a chapter. So sometimes I may lump those chapters together, a couple of chapters together in one test. They count 40%. And then semester or final exams, that's just a test at the end of the semester is going to count 20%. Okay, that'll cover multiple chapters. Questions about the grading categories? All right. Homework. Late. So there's a comment there on late stuff. Late in general is just not accepted, right? Late work makes more work for me. It puts you behind if you get late on your work. This stuff is like building on top of one another, right? So if you get behind in math, it's very, very hard to catch up. So late work is not accepted. Yes, I understand there may be extenuating circumstances. If you've got an excused absence and you're not at school and because you were sick or some kind of family emergency or something like that, I'm going to work with you on that. But in general, stuff is due when I say it's due, right? So you got to turn it in on that day. Weekly quizzes are done here in class. If you are not in class because of some excused absence, then you're just excused from that quiz. We're not going to try to reschedule quizzes and make them up. I will be happy to give you a copy of the quiz if you want to see it, just so you know what kind of problems are on there. But you're not required to schedule some time to take that quiz outside of class if you were sick, on a particular day. Let's see. I am going to give you a course schedule. I'm kind of waiting to see. This first day of class is going to help me gauge how quickly we would move through the material. And then I'll try to get you that schedule by the end of the week, and that'll be posted in Google Classroom as well. By the way, I think I put the syllabus in Google Classroom also. Does everybody know how to get to the docs that are on there? Yeah. Okay. So if you can't find it out, let me know. I'm pretty sure it's there in Google Classroom. And this is kind of important. If you submit your homework on time and you've completed all of your homework, you get 5 extra points on the final exam. So you won't make a 0, you'll at least make a 5 on the final exam. Huh? Pretty good. The structure of the class, the way we're going to do the class, like I said, quiz is how we will begin, and then we'll have some homework questions. Now, if you come in the day of the quiz, how do I want to do this? I'm not going to mention that. If you come in the day of the quiz, expect the quiz first, and then we will answer questions afterwards. So like I said, if you bombed a particular problem on the quiz, if you have tried to reach out to me during the week, and maybe I didn't have time to get back to you, and I may say, hey, we'll go over that in class before we take the quiz. Okay, so there may be times that I do that, but in general, I would like for us to take our quiz first, and then we'll deal with questions afterwards. New content is what I'll spend the last 60 minutes of class talking about. And we're already way behind on that. And then schedule will be modified when a longer exam is taken in class. So everything. There's a couple of things on here that will help you. Extra resources. Khan Academy is always an option, right? If we're working a particular type of problem. Microsoft has this thing called Math Solver where you can enter in a problem and it'll solve it for you. So you can kind of check that out. I've never used that before, but I just found out about that. That might be helpful. And then I give you a playlist on here because there's a teacher called Miss Lisa online, and the teacher last year, she had them watch Miss Lisa's videos all the time because she didn't have time to lecture on stuff in class, and so she would have them watch Miss Lisa's. I don't want to do that at all. Miss Lisa's the backup. Okay, so my intention is to always lecture on the material, but if you want to see someone else teach it as well, she goes through the exact same book that we're using. So it's kind of cool. You can go to that particular chapter and she'll go over the same material. But that's another thing that you can do, and I don't know if I'm going to record it all year long, but my intention is to post videos when I record them online as well, so you can always go back and rewatch something if we wouldn't do it too fast, right? But please speak up if you have questions, right? Don't assume that you're the only one that's confused about this, right? If you've got a question, other people probably have the same question. That is so true. And whenever someone has a question, it's just not uncommon for multiple kids to come up afterwards and go, I didn't really understand when you did da-da-da. And it's like, I wish you'd ask in class, but there's probably 5 kids that just walked out the door that had the same question, right? But they're not sticking around to find out. Those documents, by the way, if you go to classwork and then to go to the class drive folder. Yeah, the geometry syllabus is there, right? Okay, let me shut this down. I'm going to be on the juice for your science class. All right. Did I already cut that off? Did you guys see me cut that off?
Yeah.
Yeah. I never can tell if it's on or off. Let's see. I just hit the
TV's
button.
still on.
It's still on?
TV is, yeah.
Okay. I just hit the button again. Did it not do it?
There we go.
Is it off?
It's off.
Okay.
It's that red light.
So-
Red light's on, it's off.
See, that's just weird to me. I want the light to be on when it's on. You know? That's I don't know who came up with that usability feature with TVs, but I'm protesting it. All right. So let's go to let's start talking about geometry. Let's go to if you've got your book. I'm going to write everything on the board, so if you don't have it, that's okay. We'll get past that today. But there are a couple of skill reviews that we have at the beginning of the chapter, and just make sure that we remember how to do this. I'm not too concerned about you guys remembering how to do 17 minus 9. I think you can figure that out, right? But I do want you to make sure that you remember this. If I do this, 5 minus a negative 3, that's the same as what?
5 plus 3.
5 plus 3, right? So tell me your name again?
David.
No, not you.
I'm Camille.
You're Camille. So you just learned a valuable lesson, Camille. Don't raise your hand because these other kids are going to steal your class extra participation, right? So since Camille was so polite and raised her hand, and she's got such a cool shirt on today, then I'm going to write her name on the board. But David, yeah, I've got to add you because you've been talking nonstop. All right. So thank you for participating. So this is the same as 5 plus 3, so that's 8. Make sure that you know that, right? That you guys aren't confused about that. If I have a number like this, negative, or a problem like this, negative 5 minus negative 6. Don't raise your hand. Come on, tell me. What?
Negative 5 plus 6.
Negative 5 plus 6. Right. So it's 1. So that's the same. Negative 5 plus 6 is the same as 6 minus 5. Right. So if you're still struggling with that, and I'm always, there's always some kids that come in. It's just like certain basic things like that, they slip through the cracks somewhere along the way. So make sure that you know that. Tell me, who was it? What's your name?
Ian.
Ian.
I.
All right. Let's see. Anything else here? What about this is a good one. Well, they don't really do it like that. Let me just ask this question. What does that equal?
Negative 4.
Negative 4. How many agree that that's negative 4? Come on, none of this, no. Me, Mr. Walker, I'm committed to negative 4. How many of you think that it's positive 4? Okay, we've got a couple of brave souls, All right, you guys are wrong. But what's your name?
Me?
Yeah.
Liana.
Liana? Okay. Just because you were assertive, you were bold. I mean, your hand was, you almost touched the ceiling when you did that.
I have warm arms.
But why is this negative 2 squared not positive 4? And the reason why is if there are no parentheses like this, encapsulating the entire negative, it only applies to what's just to the left of it. So it only applies to the 2.
I was looking at the bottom one.
Oh, you're looking at the bottom one. Okay. All right. So yeah, this is 4. This is negative 4. So make sure that you know that. If there are no parentheses there, the square does not apply to the negative. It only applies to the 2. Okay? So that's important that you remember that. And then, let's see, square roots. Who remembers, so like here's one like this. Square root of 9 plus 9. If I do that, that's the same as square root of 18, right? So square root of 18, can I simplify that any further?
It's just 9.
It's just 9?
Just take it out of the square root.
So you're saying this whole thing equals 9?
Yes.
No? No? Let's talk through that. What is 18? 18 is 9 times what?
9 times 2.
You were thinking 81. Did you flip it in your head? See, that's the kind of thing your mind will do to you, right? It's like 18 and you're thinking 81 because that's what you flipped it in your head. My son the other day is a math whiz, and he did not, what was it he took? Oh, what was it? It was something cubed. It was 3 cubed. It was 3 cubed, and he wrote down 9. And I'm like, Joshua, what is 3 raised to the 3rd power? He says 27. And I was like, well, why did you say it was this? And he's like, I looked at it and I thought 3 times 3. I didn't think 3 cubed. I thought 3 times 3. He knows the answer to that. So it's the same way with this stuff. This is the reason that I'm saying that. This is the reason I wanted to point that out. Always write your work down and show me what you were thinking, so that if you do something like this and you say equals 9, I go, okay, they knew that the square root of 9 plus 9 was the square root of 18. But I can see how they flipped that in their head, and they were taking the square root of 81 when they did that, right? And so what that means is I'm going to give you some partial credit, even though you got the wrong answer for the problem. So always write down the steps that you're going through so I can kind of see your train of thought. Now this is the same as the square root of 2 times 9, right? And you can't take the square root of 2, but you can take the square root of 9, which is 3. So the final answer for this would be 3 square root of 2. Does everybody remember that, right? It may have been a little while, but you gotta recall that stuff. You gotta dust off the cobwebs, right, and get that back out again, and start thinking mathematically, because math can save lives, right? We've established that already. All right, that's all we're going to go through as far as review. There are some other problems there in the book if you want to look over those and just make sure that you remember how to do that. And you can reach out to me or Khan Academy or whatever. By the way, I do offer private tutoring. I do that online. It's $40 an hour. If I'm here at school, if you want to catch me at lunch, like a little early for class or whatever, and you have a question, there's not going to be time after class because I got a class right after this. But computer science is my last class of the day, so that ends at 3:30. So most days, if I don't have to, my son's in that class, so if I don't have to take him to work and leave immediately, I've got time for questions after that class as well, right? You can email me questions, I can do it that way. But if you need like more personalized one-on-one, if you're like, I'm just falling behind, I'm really not getting this, I do offer for $40 an hour private tutoring online. Okay, so just let me know if any of you need that. And that seems to be kind of the standard going rate for the teachers around here. All right, let's look at page number 3 in the book, and this is just about recognizing patterns. We've only got about 30 minutes, so we're going to try to not dilly-dally and get through all of this. So recognizing patterns, and does it make sense to everybody? If I won't do the whole thing that they've done, but if I've got a set of blocks that look like this, and so I see this pattern, right? Does it make sense to everybody that, let me draw it like this. Does it make sense to everybody that would be the next figure, right, that comes? So you see how that pattern is happening there. And there's different ways to think about it whenever you're looking at kind of trying to figure out puzzles like this. You can think of that as we're adding another row to the bottom each time, or we're adding another row to the left each time, or you can kind of think we're adding a diagonal row. Either of those would work as you're thinking about this problem, but it's just recognizing that pattern as it progresses on, right? So a lot of what we're doing in when we're especially doing proofs, which we're going to spend a lot of time on in geometry, is we're kind of recognizing those patterns and making sure that we can understand what's expected next. What about this? Is that right? Yeah. What number would come next?
128.
128?
256.
So I'm seeing 4. The way that I'm thinking about this is 4 times 1. This is 4 to the 0, 4 to the 1, 4 squared, 4 cubed. So it would be 4 to the 4th power, whatever that is, right? What do you get when you punch that in?
256.
That's 256, right? So does everybody see that pattern? Now someone said 128, which would have been doubling it. But if you kind of examine what you had before, well, that we didn't double, right? I didn't double 1 to get 4, and I didn't double 4 to get 8. So do you see how it would have to be 4 to the power there? So again, sometimes you have to think about it. It may not be immediately what you think the pattern is, but as you kind of look at it a little, test what your theory is, and if your theory won't hold, then come up with a different one, right? What about this one? 25. So let's see. This is what I think is happening here. We added 3 to this to get -2, and then we added 6 to this to get a -4, and so we add 9 to 4 and we get 13. So if we add 12 to 13, 25. Who said 25? Right there? What's your name? 80? Okay. All right. So does everybody see that? So what we want to do is we call this inductive reasoning. All right, and there are 3 steps to inductive reasoning that you need to kind of remember. This is how you tackle these problems. So inductive reasoning says do this. First of all, look for a pattern. Right, that's what we were doing in those problems there. We're looking for a pattern. Then number 2, make a conjecture. Conjecture. So that was what I called my theory a minute ago, make a conjecture. And a conjecture is simply an unproven statement, based on observations. And then finally, verify the conjecture. So it's got to be proven. And so, like when we were doing that one a minute ago, where someone had said after 64 came 128. I can see where that might pop in your head as you're initially looking at the patterns and go, yeah, you just doubled the 64. But then when you go back and you test that out against the previous numbers, that's when you realize, oh, my conjecture is incorrect, right? So I need to come up with something else. So that's kind of the 3 steps that you go through using inductive reasoning. So let's do a problem on page 4. And example 3 gives us a conjecture, and she asks if we can finish this question, this conjecture. The sum of the first n odd positive integers is blank. Is what? And so the sum of the first n odd positive integers. And so what we do is we start adding together odd positive integers. So we start with 1 and 3. So 1 and 3 when added together is 4. Actually, they started with just 1. I just realized that. 1, so I guess they just did 1 and 0. And so now we're going to add the next positive odd integer on there, which is 5. And so 1 plus 3 is 4, plus 5 is 9. And then we do 1 plus 3 plus 5 plus 7, and we get 9 plus 7, which is 16. We could take it out one more, 1 plus 3 plus 5 plus 7 plus 9, and that's going to give us 25. And as we start working that out, we begin to see a pattern here, right? And what's the pattern?
You use all the odd numbers and you keep adding one odd number after.
Right, but as we look at the answers, as we look at what we get here, does anybody notice anything about all these answers that we get? Something unique about all of those numbers? Yeah?
They're all squares.
They're all, you can take the square root of all those, they're all perfect squares, is what we would call them, right? They're all perfect squares. This is 1 squared, this is 2 squared, this is 3 squared, 4 squared, 5 squared, right? Does everybody see that? And so what it means is that if we look at the odd positive numbers, if we start adding them together, starting with 1, then however many numbers we've got as we're adding them together, you take that number of numbers, here we have 3, and you square it, and you'll get what the sum of those numbers are. Do you guys see that? So right, we have 4 numbers here, 4 odd numbers here, and that's 4 squared, which equals 16. And so the answer to our question, or what should go in the blank in our conjecture, is the sum of the first n positive integers is n squared. Whatever the number of integers are, that number squared will give us the sum of those integers. So if I was to ask you now, if I added up the first 9 odd positive integers, what would that number be?
81.
Be 81, right? Because 9 squared is 81. Excellent. Are you already on the board? What's your name again? Brittany. I knew that. Okay. So it makes sense to everybody? And again, you could work out a few other problems just to see if your assumptions were correct. Here's the way that you verify the conjecture. If you can come up with one example where your conjecture is not true, then that's how you verify that your conjecture is not true, right? So we only need one example. So in order for your conjecture to be true, for conjecture to be true, must be true for all, how do they phrase that there? Must be true for all cases. Only need one counterexample to disprove. All right, so if you make a conjecture and you're trying to figure out if it's right, you just need to come up with one scenario where it's not true in order to disprove your conjecture. And so, for example, I'll let you write that down. Finish writing that down. As I write down what the next example says. So I kind of simplified the statement instead of writing it all out, just wrote it that way. But the conjecture is that for all real numbers x, all real numbers, I should put an x there. For all real numbers x, x squared is always greater than or equal to x. And so the first thing we have to remember with that is what constitutes a real number. Does anybody remember what real numbers are? Learning about that? Yes.
A real number would be 1, 2, 3, 4.
Okay, those would all be included in real numbers, but that's not all of the real numbers. Those are integers that you're counting there from 1 on state, and you're not using any decimals or fractions or anything. Yes.
Real numbers is anything that is not a fraction or decimal.
Anything that is not a fraction or decimal. Okay, that would not be true either. Those are called what's the correct term? Because when you start including the negative numbers, I'm gonna have to look up the definition. A real number does include decimals. All right. So did anybody have a different definition? Yes.
Any non-zero number?
Any non-zero number? So we have whole numbers, and I'm asking you guys a question, and I didn't think to look it up before because I don't remember all the definitions either. But I think a real number would still include 0, but it includes all the numbers in between, basically like everything on the number line, right? You guys haven't learned about imaginary numbers yet, yet, right?
No.
No? Some of you have? So some of you are seeing imaginary numbers. So those would not be real numbers, right? But everything else would be a real number from negative infinity to positive infinity, all the numbers in between them, right? And so can we think of one example, one real number example, so that includes decimals and fractions, where this is not true? And we can, because, obviously if x equals 2, for example, if we just pick a number like that, well, 2 squared is definitely greater than or equal to 2, right? Because that's 4, which is greater than or equal to 2. And if I take a negative number, like if x equals negative 3, then negative 3 squared, negative 3 squared, is that greater than or equal to 3? Yeah, that's 9, right? Which is greater than or equal to 3. But what if I take a fraction, right? What if I do 1/2 squared? Is 1/2 squared greater than or equal to 1/2? When we square 1/2, do you guys remember how to square fractions?
Yeah.
How do you do that?
You take the top number and then multiply that by itself, and bottom number multiply that by itself.
Yeah, so if you've got 1/2 squared, that's the same as 1 squared over 2 squared, right? So that equals 1/4. So this says that 1/4 is greater than or equal to 1/2. Is that true? If I give you 1/4 of the pie and I give the person next to you 1/2 of the pie, who has the most pie? What's that? The person next to you, that's right. The person with half a pie. You only got a quarter of the pie, right? So this is incorrect. This is not true. So we just proved we just gave one counterexample to our conjecture. So we've disproved our conjecture, right? That's not true. We have to go back to the drawing board and start with another one, all right? All right, let's see here. Any questions about conjectures and how you encounter examples and that sort of stuff? Inductive reasoning. All right, let's start with. So we got a lot of definitions in our next section here, and we're mainly just going to be kind of defining some terms to make sure that we're all on the same page. And these, I don't think any of these are going to be mind-blowing things, right? It's stuff that you've seen before. A point. A point is just. It has no dimensions, represented by a dot, right? You write the word dot. So we've seen that before, right? We have a Cartesian coordinate system here, and I could plot a point at 4, 4, right? And it's just represented by that dot on the graph. Now a line extends in one dimension always straight. Lines are always straight. So when you say a straight line, that's kind of redundant because they're always straight. You don't have to specify the straight. And it's without, by the way, I tend to abbreviate with W slash, so without N in both directions. So if I drew a line that was through that point there, let me draw a line across somewhere up here. All right, I would put arrows on each end of that line there to signify that it just keeps going. And I might label that line with a cursive L, like that. Or I could label these points A and D right there on that line. And so if that's the case, I could either say that that's line L, or I could write it as AB with a line with 2 arrows over it. over the AB. Okay? So this is kind of the shorthand that you're going to see us use probably most frequently here. Where we'll write 2 points down, and then we'll have the little the line with the arrows on each end signifying a line. Okay? A plane, you can think of that as like the wall here or the board would be a plane, but it extends out. A plane is like a line in that it doesn't have any end. It extends in 2 dimensions. So, like the paper, this would be sort of how to think about something in 2 dimensions. Right? If we think of something 3-dimensional, that's anything that kind of comes out this way as well. So like a cube, we're in 3 dimensions, right? We're not flat like this, but this would be sort of like represent a plane, and it looks like a tabletop, a wall, looks like a table top or a wall. Extends without end, just like the line does. Without end. So when we think about planes mathematically, we don't think of them having an ending point, but we clearly, just like with lines, we can't draw that, without end. So you might draw it like this. And for this one here, we could label some points A and B and C, or we could put an elm up in the corner. And so for this one, we would call it either plane elm or plane ABC. So we're having to define these things because as you start doing the problems, you got to know what we mean when we say plane ABC or plane elm, right? So that's why we're writing these definitions on the board. Now, if we have points, I'm going to add C here, and then I'm going to put a point D over here. A, B, and C, we would say that all of those points are, A, B, and C are co-linear points. All right? On same line. D would not be collinear with A, B, and C. Does that make sense to everybody? Because they're on the same line, they're collinear. A, B, and C in this drawing are coplanar points because they are all on the same plane. All right. So again, if you see that definition, be able to recognize it. One of the things I might have on a quiz next week is I might give you some definitions like that and say you got to match the definition with the match the word with the definition. All right. So you should be able to tell me that coplanar points are points on the same plane. It means they're on the same plane. Collinear is on the same line. Be able to define a line and a plane. Just again, some terminology stuff. Make sure that you know this. This would be, like we said, this would be a line. And so we could write that as line AB by just saying AB with the line over it. But you could also have, so that's line AB, would be one way to write that. You could also have line segment. Or segment AB, and the way we write that is AB with a line with no arrows, all right, over it. And so the segment portion of this would just be that, starts and ends on points A and B. And of course, it would include all the points in between it, but A and B signify the beginning and ending point of the segment. We would say A and B are endpoints. That's what we call those. All right, so know what that term means. Know the term line segment or segment. Something else we can have with this line here is that we can start at A and only go in the direction to the right, passing through B. Does anybody know what we would call that? Yes?
Array.
Array, right? This would be ray AB, and we signify that with, like you might expect, only an arrow on one end, right? Now I can also draw this line here, AB, I could draw a ray that way, or I could draw a ray this way. And we would say, whereas this is ray AB, we would say this is ray BA. So the letter on the left signifies the starting point, right? The end point. But something that we need to understand is that we're allowed to kind of flip these letters around. So AB for a line, AB equals BA. And for a line segment AB equals line segment BA. We could write those either way. But, like we showed right here with this, AB does not equal BA. Rays you can't flip around, because that first letter there signifies the starting point. And then one other thing about rays, let me do this. Actually, do it like this. So in this case here, see if this one writes. Yeah, it does. Cool. So I can draw this ray here. Right? So we could say that ray, CA and CB, right? So CA is that ray and CB is this ray, and they are what we call opposite rays. Right? Notice they both start with C, so they have the same endpoint, but one goes in one direction, one goes in the other direction. So those are opposite rays. So example 2 and 3 on page 11, let me just go over those real quick. I'm not going to do everything, but just to make sure we understand some of these definitions. And that's really what this homework's more about, is getting the definitions. So if we have K, we did J, K, L, and you were told to, the first thing it says was draw 3 non-collinear points, JKL, and then draw a line JK. So if we needed to draw a line JK, I should have put my J and my K somewhere different, so K and then J. So our line JK would go through both of these points, and it would have arrows on the end. So that's line JK. We would identify like that. And then line segment KL So I wouldn't have arrows on the end, but I would connect those two dots from there, and we would say that's line segment KL. And then the last thing they said was draw ray LJ. So ray LJ, since L is to the left here of this ray, then this is the starting point, and we have an arrow on the other end there. So that would be ray LJ. So did everybody follow those pieces as I wrote those down and then connected the dots appropriately? See why I did it like I did it? Any questions about that? Remember, if you've got a question, someone else does too. So. It's supposed to be K. It looks more like an I. Yeah, there we go. So the very last thing that I want to say is if I have two lines like this, and this, everybody's going to be like, duh, but again, we're doing definitions here, right? Then we say those two lines, what? Intersect, right? So two lines intersect, two or more, I guess, again, just our last definition. Two or more geometric figures intersect. If have one or more points in common. Alright, so in the case of a line, they just have this one point that's in common, but as long as they have a common point, at least one, then those figures are said to intersect. And this is called the intersection, which again should be obvious, but that's the intersection of the two lines. So again, just definitions as you do these problems. If you see a word like that, we just want to make sure you know what it means. But of course, it doesn't have to just be a line, right? We could have two planes. I could have two pieces of paper. If I can stick this paper through here, right, they would intersect, and there'd be multiple points at which they intersect. So you have different shapes that intersect, and that's why we say one or more points in common. All right, that's it for today. We are out of time, so I don't have time to write the assignment on the board, but Lord willing, I'll have that there before you get home today. You'll be able to see what you're working on. I'll try it as soon as I get done with the computer science. I'll put that into class. Okay?